session, that is the valedictory ceremony of this 1 week FDP. And as far as the quiz is concerned, so I will share the link of that quiz during the valedictory session, and we will give you sufficient time to complete that quiz. So don't worry for the quiz. You have joined us from number of days. You have participated in this FDP, so we will take care of that also. So now I request Dr. Ajay to start with his presentation. Dr. Ajay, please.
Yeah, sure. First and foremost, sir, I can share my screen so that it will be helpful to every individual to understand the concept in simpler way. Sir, I hope that my screen is visible perfectly and voice is audible.
Yes, everything is fine, sir.
That's great.
Okay.
So first and foremost, I congratulate Dr. Shastri, sir, for organizing this wonderful faculty development program on machine learning concept and application by Kato Campus, Jammu. I also thank the organizing team and dear participant. Last 1 week, we are witnessing amongst the machine learning concepts where algorithms, their way of doing the different analogy in terms of data prediction, data analytics, predicting a different sort of examples. And not only different sort of examples, we are witnessing amongst the various algorithms which is implementing on a different data sets, and we executing some of the hands-on session on machine learning concept as well. Today we are going to discuss the logistic regression in machine learning, what exactly the importance of logistic regression in terms of data analytics, data science, probabilistic distribution, and they are more overall rid of logistic in terms of machine learning is concerned. Now let's talk on what exactly we are going to be cover in this particular presentation. First and foremost, we are going to discuss what exactly the LR is all about, that is logistic regression. Then we discuss the some of the glimpse and types of the logistic regression, which how it correlate and coefficient of correlation has been formed with the help of probabilistic distribution using LR technique or logic function. Then categorical responses of a variable, how it is being differentiable in case of a linear regression, what sort of data points we are going to be covered it, what is exactly the data point which is not being there in terms of feature extraction is concerned. So it's important to be understand the basic terminology behind it. Then binary logistic regression, and finally the case study of couple of examples which we are going to be covering in this presentation as well. So once again, I welcome all the participants, and let's start with the linear regression first, what exactly it is. As we are aware, right now, in a single minute of a time, huge data is going to be gathered on the internet, and we are witnessing among those social media is concerned as well. So the job of a data engineer is to cleaning up of a data and coming to the point, coming to the conclusion that how a data is look alike. It's very important to be understand the basic phenomenon that how data is going to lookalikes in terms of their prediction is concerned. So merely we have to analyze the basic concept behind the data visualization and their data perception is concerned. In this particular case, now we are focusing first on linear regression, what exactly the linear regression is concerned. Now this is guys, we know that this is a concept of classification. This is the example of classification. Now this classification is merely dedicated to linear regression, though we know that this linear regression analysis is used to predict the value of a variable based on the value of another variable. That means dependent and independent variable is taken into the consideration while discussing on this parameter. Okay, you can saw over here a graphical pictorial representation. It's on the x-axis we have independent variable, whereas on the y-axis we have dependent variable. And some of the data points on the graphical point, you can saw some data points are there, and if you plot a line between them called as a line of regression, and in that particular line you will saw some of the data points are above the line and some of the data points are below the line. So this linear regression is going to be predict the value which dependent and independent variable that depends upon the one each other dependent variables. So this is the example of this is simple definition of a linear regression is concerned. Now, what exactly the logistic regression is all about? Logistic regression is aim is to solve the classification problem. Similar will happen in case of a linear as well, but it does this by predicting the categorical outcome, unlike the linear regression that predict the continuous outcome. If you saw a graphical representation, here the data points are collected and we are plotting a graph. We are plotting a line over there so that we came to know that what data points are outliers, which data points are above the line, which data points are below the line, and then we are going to come up with the conclusion. So here the case is not being there because of the functionality of a logit function. So what is logic function and how it is going to be used, we'll see in the next part of this presentation. What are the different types of logistic regression? So as we are aware that there are basically 3 types of logistic regression. That is BLR, that stands for a binary logistic regression, where the response is categorized into 2 different categories like yes or no, 0 or 1, and so on. Next, we have called multinomial logistic regression, where the response in a similar way, like 1 or 3 or more categories, but there is no natural ordering amongst the categories. It's very important. There is no natural ordering of amongst the categories in case of multinomial logistic regression. In case of ordinal logistic regression, the responses again belongs to 1 or 3 or more categories, but there is a natural ordering amongst the category. This is simply this pictorial view or this table will gives you what exactly the meaning of the comparison between these 3 types of a logistic regression is concerned. If you saw over here, the number of categories or for the response variable or response constraints is concerned, the binomial logistic regression is output in terms of 2 variable, or we can say in the binomial type, like either yes or no, or 0 or 1, or true or false, and like this. Okay, but in case of multinomial logistic regression, the output comes in terms of 3 or more categories. In ordinal, again 3 or more, but one differentiation between does order of category matters in case of this logistic regression. So in binomial logistic regression, no category will matter. In a similar happen with multinomial as well. But in case of ordinal logistic regression, the category matters. How exactly it is? See the example. In case of a binary logistic regression, we are doing the simple model or preparing a model called spam detection. We know that if we are preparing a model of machine learning, where we are getting a data set, we are preparing a data set where the output is either spam or not. So we are just detecting the spam of an email using binary yes or no. If the email is coming out to our inbox, whether it is a spam or not. So this is a simple category of a binary logistic regression. But in case of multinomial logistic regression, like we have 3 or more sort of preferences, 3 or more sort of output or the parameters which we are going to be taken into the consideration called features of our data set. So in case of multinomial logistic regression, there is example like political preferences. We can give 2 more than 3 or 4 kind of preferences to a political kind of a situation will be there. Next, there is called sports preferences. Okay, I think I missed some there. So it's a sports preferences where we can train the model in such a way that it will give the output accordingly. But in case of ordinal logistic regression, the example like school rating or movie rating, online movie rating, and so on. So where the natural preferences or a natural ordering is matter. How it is going to be utilized, let's see the example. This is a code for predict a tumor with a size of 3.46 mm. If you can saw over here, first and foremost, we reshape the logistic function with some values in array like starting from 3.78 to 5.88. If you can saw over here, some of the values are ranges, and the data points are plotted in such a way that their values are some of the values are in above the line, some values the data points are below the line, and we are considering the result in terms of 0 and 1 only. If you can saw over here, it's numpy.array. So either it's 0 or it is 1. This is the output ratio we are calculating. This is the output prediction which we are calculating whether the individual having the brain tumor having a size of 3.46 mm. Now, if you can saw here, we are predicting if the tumor is cancerous, where the size is 3.46 mm, then using the function called logr dot predict num dot array of 3.46 and then print the predicted value. If you can saw over here, this particular example of programming in terms of Python is concerned, we are just getting the output in terms of 0 and 1. Okay. Now, second thing, like called categorical responses. What exactly the categorical responses is all about? Categorical responses is nothing but see whether or not a person will smoke. So we are getting the output in terms of binary format, like either non-smoker or it is smoker, or success of a medical treatment either survives or dies. So this is called as a binary response, which we are getting from these particular models or questions. And if you are trained the model in such a way that if they are giving the binary output in terms of categorical situation, so the opinion poll responses that we are getting it like agree, neutral, and disagrees. Okay, so this is called as a ordinal response. So I hope that you are getting the differentiation between the binary responses and ordinal response. In case of binary response, we are getting the output in terms of two variable called x and y. Suppose yes or no, true or false, 0 and 1, and so on. In a similar way, we are predicting the questions like whether or not a person is smoke. So we are getting the output in non-smoker or a smoker. But in case of a success of a medical treatment is concerned, either yes or no, or survive or dies. But in case of opinion poll is concerned, okay, like day before yesterday, I think Saturday, Dr. Bhatia has taken a session, and on the Mentimeter, they are asking for a poll. Okay, I hope everybody's remember. So this is example of an opinion poll response that comes under the category of a ordinal response, either agree or neutral or disagree and so on. So this sort of examples will be there. So here another example that we are predicting the height of a gender. If you can saw over here, so I'm taking on a y-axis as a gender. So in genders, 0 will be treated as a male and 1 will be treated as a female. And on x-axis, we are treating as a height in inches. So if you can run this particular line of a code in Python, so we came to know that the efficiency or the estimate efficiency, standard error, value predictions, and so on. So if you can saw, the intercept values comes around like 7.34. Okay. This particular sort of analysis or analogy will gives us the basic ideology behind it. See the graphical representation between this height and gender is concerned. Here, some of the data points are merely on a above side or a below side is concerned. So we have to be very conscious about which data points are important while training up of a model is concerned or fitting up of a model is concerned. If you are fitting the model with the help of linear regression, then we have to take in the points in such a way that which points are available for the prediction, or which point data points are contributing to the prediction, that like data points which available to the dependent and independent variable is concerned. So we have to be conscious about the plot of a line or the intercept is concerned in terms of logistic regression. In case of ordinary linear regression, used a lot and it taught in every into the stat class. Like a logistic regression is rarely tough or even mentioned in the stat. Like we know the computing power of and the software to implement the logistic regression. So have to consider in case of pi, that is the proportion of success. Another example, in ordinary regression, the model predict the mean y for any combination of predictors. So what's the mean, like either 0 or 1 as an indicator value. So we have to consider this particular situation in case of linear regression is concerned or ordinary regression is concerned. Say y bar is equals to summation of yi divided by n. That means the total number of 1 divided by total number of trials. So we are getting the proportion of success in case of ordinary. But the goal of logistic regression is to predict the true proportion of success, like pi, at any value of predictor. Either it is 0 or it is 1 and so on. So we are interested to finding out the prediction of true positive value or a false positive value or a true negative value or false negative value every time in case of logistic is concerned. In case of binary logistic regression model, so we have y like a binary response, x we have quantitative predictor where the pi is a proportion of 1 either yes or success at any x point of binary quantitative predictor. So equivalent form of logistic regression is called as a logit function or a logit form, we can call it as. That is a simple equation that stands for log of pi divided by 1 minus pi, that is beta 0 plus beta 1 x, where this beta 0 and beta 1 are nothing but the predictors which we have to be evaluated after executing this logarithmic function. Okay. Next, the probability form for this equation called as a logistic function or logit function is defined as pi equals to e raised to power beta 0 plus beta 1 x divided by 1 plus e raised to power beta 0 plus beta 1 x. So guys, this is a mathematical situation or a probabilistic situation in terms of executing the logistic regression in terms of binary polynomials, where this log is a natural one that stand in case of equating the situation. What does is localized basically? So this is a logic function. Now, in case of linear regression, we are getting a straight line. Okay. In that straight line, some of the points are below the zero, like minus or maybe the negative points, where in case of logit function or a logistic regression, we are getting the curve in terms of S. Now this S will starting from merely from 0 to the maximum point, so that all the points will come towards the data situation. And hence it is called as a logistic curve or logit curve, or it is called as a logit function. Where now if we compare this code with the earlier code, if we are executing this code in the Python, we came to know that again we are predicting the height of a gender. Okay, so now we are getting the intercept of 64.14. If you can observe over here, the merely result which we are getting, it's better than the previous one as well, as the intercept of gender versus male is gender versus height is concerned. So the result of the outcome of this particular situation is quite better than that of the linear regression because of their logit function. Why this is so? Now, if you can saw over here, the intercept of which we are getting after executing the logit function is 64.14. So its value of beta 0 and beta 1. So the pi function must be its e raised to power 64.14 minus 0.94 to at ht divided by 1 plus e raised to power 64.14 minus 0.9424 ht. This ht stands for the value of a height which we are getting after executing the proportion against gender versus height. Okay. Now, if you are plotting a graph between these data points, we came to know that this is a particular function after executing the logit function over the logistic regression against the model of gender versus height. Okay. Now, if you can saw, data points are getting in a S reverse S direction, and no data point will come below the zero. If the situation like that, like the data points are coming to minus values or negative values, so that values are taken not in the consideration and generate the result as far as the differentiation of that function is concerned. Another value or another plot, if you can graph, it's again a graphical representation of amount versus the gender. So if you can situation like that, if you are plotting a graph against these two parameters, you came to know that the value of these are taken into the consideration in such a way that whatever be the data points are taken into the point of interaction into the data points that are against the values. This is a simple example or another example of golf puts where the length comes around like 3, 4, 5, 6, 7. It makes like 84 goals, 88 and so on. How many missed? Like 17, 31, 47 and so on. And total we are getting it like 101, 119, 108, 125, 134 and so on. Now we have to build a model to predict the proportion of puts made, that is success, based on the length in feet. This is another kind of approach we are going to be predicted with the help of a logistic regression. Another kind of a model that we need to be prepared against testing and training phase of a model, or fitting up of a model with the help of a logit function. And their aim and objective is to plot a graphical representation or a data visualization against the proportion of put made, that is success, against the length in feet. If you are writing a call, or we can call it as a simple Python code, that logistic regression for putting or fitting up of a model using logistic one. So its intercept is coming around like 3.25. Okay. Now its function, if you saw over here, the logit function, that is log of p bar divided by 1 minus p versus the length. Okay. You can saw over here, this putting length against the rope of a model is coming in this particular way. This is a particular graph which we are getting for fitting up of a model against the logit function. You saw over here, and if you plot a line, a linear line between these data points, again we are showing that like we are seeing that like some of the data points are above the line and some data points are below the line. This is one of the disadvantage we can call it as of linear regression that comes under the classifications concern. So this is a linear part of logistic fit function. Now, the probabilistic form of putting model you can saw over here, the majority the points are being covered, where the pi is defined as e raised to power 3.257. Here is the value like 3.2567. It's an intercept value. Okay. Now, so here, so it's 3.257 minus 0.566 in the length is concerned, divided by 1 plus e raised to power 3.257 minus 0.566 length is concerned. So we are getting the graph. Now, this is a simple study of a logistic function. Now, we came to the point of interaction that we need to be discussed. Like definition is pi divided by 1 minus pi. That means either p is yes or no. This is the odd of yes. Again, if you define it in a simpler way, like odds divided by 1 plus odd. How the odd is being defined, like pi divided by 1 minus pi. And the fair dice, like, is concerned, it is, if it is even, then it's 1 by 2 probability and odd is 1. If x is greater than 2, x is nothing but the dependent variable which we are taking in terms of their prediction is concerned, its probability is around 2.2 by 3. Odd is 2, either yes or no. And roll of a 2 is 1 by 6 and odd is 1 by 5. This is a graph which we are getting it in terms of probability distributions concerned, where x is increased by 1. Okay. Next is pi is increased by 0.72 in the earlier example is concerned. Then x is increased by 1, where pi is increased by 0.231 and the odd is comes around like 2.718. So this is a typical example where we need to predict the output in terms of logit function. This is a particular method or a model to fit in terms of data point, like log of pi by 1 minus pi, beta 0 plus beta 1 x. And the logistic model assumes a linear relationship between the predictors and log of odds. Odd ratio, like odd 1 divided by odd 2, that means the common way of comparing these two groups localized in this particular way. The odd ratio, that is OR, it's very similar to the relative risk, that is RR. Its formula is P1 divided by P2, or its OR, that stands for odd ratio, is defined as RR multiplied by 1 minus P2 divided by P1. So P1 and P2 are nothing but the predictive variables like Y, which we need to be predict. Where if we are explaining, or if we are replace this x by x plus 1, this formula is turns to be like e raised to power beta 0 plus beta 1 x. If we are replacing x by x plus 1, so it's equation like e raised to power beta 0 plus beta 1 x plus 1, and the ratio is comes around like e raised to power beta 0 plus beta 1 x plus 1 divided by e raised to power beta 0 plus beta 1 x. That is equals to merely like e raised to power beta 0 plus beta 1 x plus 1 minus beta 0 plus beta 1 x, that is equals to e raised to power beta 1. Ultimately, we're getting the exact prediction amongst the data points. Another example of TMS for the migraines, like transitional magnetic simulation, that stands for TMS, versus placebo. Like either it is a pain-free or yes or no. The TMS, like we are getting some value 3961 and placebo stands 29, 22 and 78. If you are plotting the value of the logic function is concerned, so pi of TMS is 0.39. Okay, then odd of TMS we are calculating 0.6. Pi we are getting 0.39. Pi of placebo is 0.22 and odd is 0.282. That means the odd ratio is comes out to be like 0.6 0.39 divided by 0.282, its answer is 2.27. It's an odd of ratio. Here, plotting a graph of a logistic regression for the TMS data, its answer is like e raised to power 0.8184. We are already implementing this theory to our to model as well for preparing the detection of a brain tumor. Its answer is around 2.27 odd value, but the group TMS it comes around like 0.00977. This is another theory or another test called chi-square test for two-way table, where we are getting the different data points for the performance of chi-square is concerned. So its x squared values comes around like 6.818. Their data frame is 1 and p value is 0.00903. And the similar says the binary logistic regression is comes around like 0.81 and error is around 0.3167. Now, the single binary predictor for a binary response. So response variable around like y is success divided by failure. Predictor variable x, that is group 1 divided by group 2. So we are implementing these three situations or three methods. Like the method 1 is like around binary logistic regression. Method 2 is z test, compare the two proportion, and method 3 is chi-square test for two-way table. Okay. So this is the example we are taking, like odd values for 6 feet is 0.9, odd values for 5 feet is 1.298, and hence the odd ratio among 6 feet to 5 feet is 0.953 divided by 1.298. It comes around 0.73. That means the odd of making a put for 6 feet are 73% of odd of making the 5 feet. This is another example of goals put data. The 5 feet odds comes around like 1.298. Now, where this data is comes around like value of a p. The value formula for p is like p is equal to 1 minus p divided by total number of p. So it comes around like 0.5678 divided by 1 minus 0.5678. It's 61 divided by 46. 61 is like value of that made. Okay. Next is 47. That the value of a missed is comes around like 1.298. For the 6 feet odds, is value is comes around like 61 divided by 64. 61 is made divided by 64 is missed one. Its answer is like 0.953. Again, the total odd is concerned. It's around like 4.941. Intercepting the slope, like we are knowing that in case of a straight line, we are having the equation like y is equals to mx plus c, where m is the predictor variable, y is the predictor variable, m is the slope, c is the intercept. In a similar sense, we have the logit function. It could be defined as log of pi by 1 minus pi. That is also been defined as beta 0 plus beta 1 x. If you go into the details of logit function, you came to know that like we need to calculate the odd value of it. Like it's e raised to power beta 0 plus beta 1 x. Where we increase the x by 1, the value we are getting it like this is example which we are increasing the value by logit function by 1. So 4 to 3 feet like 0.5, 5 to 4 feet like 0.4, 6 to 5 feet 0.7, 7 to 6 feet is 0.5. So from the fitted logistic is concerned, we are getting the value like 4 to 3 is 5.5, 5 to 4 it's 0.5 again, 6 to 5 and 7 to 6 the value which we are getting it as a same one, and it's called as a constant values which changing according to the predictor is concerned. This is the example or a graphical representation. In 2012, a Democrat had a decent chance even if the Obama got only 50% of the vote in the district. In 2014, that was the least true value. If you saw here, the dotted green line is concerned, this is the actual graph of the prediction has to be made by the election commission or the predictors or the data engineers at the time of 2014, and that is the least two values which we are considering here. Okay, and the majority of the data points here comes around, it is a 50% of chances of Obama get win. So this election predictions comes under the ordinal logistic is concerned, where we are getting the exact kind of logistic curve in the data point is concerned. The simple code that we are going to be implement in R programming. Okay, if we saw over here, this is another example of fitting up of a model using the null values. So it comes around like deviation of 80 percentage. Two forms of logistic data. First one is response variable y, that is success divided by failure, and response variable y, that is number of successes of a group of a data with the common x values. That is the short form. Some of the example in R programming to describe the logic function. Next is called binary logistic regression model, where y is a binary, x is a single predictor. It is not in a 2 to 3 ways of kind of generating the results, where pi is a proportion of 1, that is either yes or a success at any point of moment x. Again, the logic function is remains same, like log of pi by 1 minus pi, that is beta 0 plus beta 1 x, and the probabilistic form is pi is equals to e raised to power beta 0 plus beta 1 x divided by 1 plus e raised to power beta 0 plus beta 1 x. So another example, like if you are taking the multiple sort of predictors like x1, x2, x2, x3, and so on up to xk, then the equation is going to be changed, like beta 0 plus beta 1x, beta 2x, and so on up to beta k xk. Whereas pi, this probability form, it turns around like e raised to power beta 0 up to so on, the k sort of values. So this is the another study where the ICU functions. Another study which we are going to calculate it. Here the multiple values are taken into the consideration up to like k values, and at the different point of moment, the two lines are being plotted here. First one is red and second is blue, where red is giving the line of prediction of a voting, and blue is a auto industry contribution towards that voting is concerned. Finally, the quiz time is concerned. Last one, like generalized linear model. So what is the link between y and beta 0 plus beta 1 x? Answer is logit. Option A is regular. Option B is logit regression. Option C is Poisson's. Second question is like, what is the distribution of y in given x? So regular regression, logistic regression, and Poisson's regression. So the first answer is logistic regression, and second one is binomial logic function. So that's it from my end. This is a simpler way of approaching towards the logistic regression is concerned. This is a mathematical model actually to be implementing.
Thank you so much, Dr. Ajay. It was a nice presentation on logistics regression. So dear participants, if you have any queries regarding the topic logistic regressions, you can unmute yourself and directly talk to Dr. Ajay. Or you can also write your question in the chat box so that I can communicate the same to Dr. Ajay. Dr. Ajay, there is a question from the participants.
Yes, sir.
When we have to apply linear regression and when the logistic regression?
Sir, if you are doing the classification in a simpler way, like the classification of fruits, classification of iris data, classification of Walmart data, you go with the linear regression, where the data points are very simpler, either yes or no, true or false, 0 or 1, and so on. Where you have a complex data, where you have to predict the value by more than 3 or 4 and so on, at that particular time, you go with the logistic regression.
Okay. Thank you. One more question from Dr. Suman Agrawal. How logistic regression can help in clothing?
Yes, very important question. And thanks to Agrawalji. Ma'am, in case of LR, in case of example, if your clothing is concerned, you first go with the preparing a model, and that to be in such a way that the quality of a cotton, then clothing is concerned. Secondary, the price of that particular cloth, then comes around the method that you are preparing or delivering to the customer and so on. So where the logistic regression with the binomial will help us more in case of clothing is concerned.
Okay, sir. Thank you.
Sorry?
Thank you, sir.
Thank you, ma'am.
Yeah, she's satisfied with the answer. So any other queries? Okay, so thank you, Dr. Ajay, for sparing your time and for interacting with the participants of this 1 week machine learning FDP. And that was a nice presentation on logistics regression. So,
Thank you so
dear
much, sir,
participants,
for giving the opportunity.
welcome, sir. So, dear participants, I think there is one more query.
Yes, please.
Dr. Ritesh. Okay. So, dear participants, this was the last technical session of this 1 week FTP. And now it is 1:45 and we will meet now at 3 o'clock for the final, the valedictory ceremony of this 1 week FTP. As far as the quiz is concerned, so I will share the link for the quiz during the valedictory session, and you have to appear for that so that that is required for getting the certificate. I have already shared the schedule of the valedictory ceremony in the WhatsApp group. So at 3 o'clock, we will join again, and there are very eminent resource persons, Dr. Milind from Merit and Professor R.S. Laria, who has various books on the programming languages like C, Python, even numerical methods. So he will join us at 3 p.m. So let's meet at 3 p.m. now. Thank you very much for your patience, for your cooperation, and for participating in this 1 week FTP. Thank you so much.
Thank you, sir. Thank you so much.